everybody again for coming out today. This is my third tour of ASU for this Renewable Energy Conference. It's always a big, great pleasure to be here. I appreciate you guys asking me to come back. Well, I want to ask you guys, this is a question I usually start with. What's the first thing you need if you're going to build a structure on this planet? What would you say would be the first thing you need if you're going to build a structure on this planet? Anybody?
Location.
Land? Pardon?
Location.
Permit? That's money, maybe, the foundation? Well, I'm going to suggest that the first thing you need is a smartphone. No, actually, you need a smartphone with a compass, okay? A compass is the first thing you need if you're going to build a structure on this planet. And the reason I say that is if you ignore the sun's influence on the operation of your building, it will make you pay and pay and pay every day by putting windows in the wrong location. You may not know it, but for every square meter of glass taking direct sun, you need another ton of cooling load to keep that space comfortable. Think about all the windows that are in the wrong location. It's happening every day in buildings and homes all across the country, and this is known information going back thousands of years. Our ancestors figured this out a long time ago, but we routinely and continuously dismiss this very simple fact about how do you build a comfortable environment to live in. Now, I don't know about you guys, but the years are flying by. All the technology we have, all the information, everything at our disposal, we are seeing the years just fly by. Well, a lot of, this isn't rocket science. The only reason I keep bringing this up is everywhere I go and I see new construction, it's dismissed. We're like, come on guys, let's get with the program. Let's build a sustainable structure. Let's make it energy efficient, and let's consider what the sun is doing to us, right? So the point here is the sun's higher in the sky in the summertime and lower in the wintertime. So you want to orient to the sun. This is a simple little diagram showing a little insulation and some mass, if you will, overhang here so that the summer sun does not strike the glass. It's hitting here and here. It's not hitting there, except in the wintertime when you want it to. Now in Arkansas, we have to be more concerned with staying cool, and actually maybe the whole planet is going to have to be worried about that. So having building integrated awnings that provide shade so that the sun doesn't strike the glass in the summertime, you can lower your cooling load by 50% versus dismissing it and then having the oversized heating and cooling equipment to compensate for it. Now, what do normal designers, developers, architects, homeowners, business owners, they want to orient their building to the street, right? Or to the river, or to the view, or to the whatever. And they get so far along, and that's what they're going to do. Well, this little graph is saying, if this is your street, doesn't matter where your street is, this is the best orientation. Because again, we're talking north, south, north. So here's perfect orientation, perfect, perfect, perfect. These are your do not cross go areas, but it happens every day, all over the country, even in Jonesboro, Arkansas. People are dismissing the influence of the sun on their operation of their structure. Now, the angle of incidence. What does that got to do with anything? Right? Well, if we build a structure that incorporated the sun's influence, and now we've lowered our potential utility bill otherwise by at least 50%, how about we create our own energy? How about we create a little bit of energy independence? As I mentioned Bill mentioned it earlier, and mentioned it in my little bio. I built a house that I wanted to be earthquake resistant, tornado resistant, fire resistant, energy efficient. Now, are all those things important today? I would think that they are. Now, I've got a little couple of teaching aids over here. This is a core sample out of the wall of the house that we built in 2002. Now, I don't know if anybody's seen this before. This is a core of an insulated concrete form. This is like the strongest building envelope material components you can find on the planet. And you can get the concrete a lot thicker if you want to. A 2x4 firing 250 miles an hour, this thing just bounces off. You know, Texas Tech does those testing. They turned their model around, shot it on the other side, it bounced off. It's like, we've never had anything do that before. So, do we have to worry about what Mother Nature's going to throw at us in the future with unpredictable winds and so forth? Anybody recognize this? What I like to point out about these two building materials, you can use them together or separate, and you can't build your roof out of this stuff, but this is a surface area, whether it's inside of the house or the outside of the house. And this thing weighs about 30 pounds, right? Here's the surface area of a structural insulated panel. Look at all that compared to this. I mean, it's 5 times as much surface area, and it weighs 1/5 the weight. But the point here, you can build your roof out of this, you can build your foundation and your walls out of that. You need to have an F5 tornado. The only place it's going to get you is through the glass. It won't hurt either one of those building components. Angle of incidence. If your house is set up for solar electric array, it's luck. Your house wasn't designed with the sun in mind. And so, depending on what angle you're approaching the sun at and what tilt you have determines what your output is going to be on your solar array. All that stuff is measured when it comes down to determining how much space do you have available, how many kilowatt hours is it going to create, what are you currently using, so what percentage are we going to be able to offset. Now, energy efficiency and renewable energy. Those are the small players in this field, if you will, today. I would submit that we are here with energy efficiency and we are here with renewable energy. This is what we're doing right now, the white space. Coal, right? Coal is white, right? So that's what we're doing. This is what we need to have energy efficiency and renewable energy and what we're currently doing to solve any issue that we have. Anybody believe that we could be better stewards of the planet? That maybe some of the things that we're doing aren't really the best things for future generations? I'll throw this out. I'm the 10th child of a family of 14 children. I've got 35 nieces and nephews, and I got 22 great nieces and nephews, and we always got 3 or 4 in the oven. And so I'm very concerned. What I do is not necessarily for me, and it's not even necessarily for my children. But my children are having children, and they're going to have children. That's who it's for.